Okay, so this would be the last topics under the power generation. We will cover some kind of advances in power generation industry in general. But the main point highlighted in this topic would be on the alternative energy, okay, or shall we can also say is renewable energy. We'll cover maybe just on the surface, on the background, on how these technologies are adopted in power generation industry. And then the second part, we'll be covering on the pollution emission, and what are the technologies available to minimize this pollutant. So that is two of the main subtopics under this chapter on the advances in power generation. But before that, we will look at the overall scenario on the sustainability of the power generation industry, okay, throughout the world. Uh, right, motivation for the quest of power gen alternative. Okay, people or engineers has been looking for a more efficient way of producing the power. Okay, more sustainable, okay, cheaper, cleaner, and also more reliable. These are the five important factors that we are looking at, okay, when we look for alternative for the power generation industry. Okay, as you know that business of power generation is involves security of the country. So we have these four A's, okay, that describe how important it is, okay, to the country in terms of their availability, accessibility, or acceptability among the community or among the people living in the country. And last but not least here is the affordability. Okay, the price of electricity that we sell, it has to be affordable. So if you look at the alternative energy or renewable energy, previously back in the 8th National Plan, the country only targeted around 5% contribution from the renewable energy. Okay, but by the, I mean, in the latest development, okay, the new target for renewable or alternative energy has increased significantly. Okay, we target to have 20% contribution of the total power generation, okay, should come from the RE. Okay, that is the target by the end of 2030. Okay, when we talk about renewable energy and things like that, we cannot run away from this term sustainability. When you complete your degree later on, okay, when you come out, definitely this issue of sustainability it will be talked about. Okay, so make sure you are well prepared on how do you define this sustainable engineering, okay, in technical term. Okay, whatever we do, especially when you want to develop new technology, okay, we have to make sure that this development must meet the need of the present, okay, without compromising the future generation. So that's the fundamental definition of the sustainability. And then this sustainability, usually we can divide it into three main important sectors around the world in terms of the economy, in terms of the social, as well as in terms of the environment. Okay. This is another thing that people are talking about nowadays with regards to the United Nations Sustainability Development Goal. Okay, we have 17 areas that needs to be looked at. Okay, you can just go through here. We want there is no poverty, hunger, okay, good health, good education, gender equality, clean water and sanitation. Okay, renewable is one of the important UN Sustainability Development Goal. Okay, the renewable energy is one of them, and then the rest you can just go through. So Malaysia has committed to the post-2015 agenda with regard to the sustainability development goal, and that's why we commit ourselves to get our 20% electricity generation come from renewable energy by the year 2030. Okay, I think this is outlined in our 11th Malaysia plan. And because of that, all the power generators in Malaysia, they are, I mean, the business model has to change significantly, okay, just to cater that target of 20% RE. Okay, when we talk about the renewable energy, then we look at our Malaysia's green technology policy and strategy development. So there are changes in the policy. Of course, the policy need to be changed according to the current local as well as international scenario. Okay, this policy is important because you want to make sure that all the players are abiding to our target of 20% RE. So there must be some kind of act or guideline. Otherwise, I believe it is kind of difficult for us to reach the target of 20% because you have to have some kind of rules and regulation so that all these players, okay, will follow this rule in order for them to get their business. So this is a kind of historical overview with regards to the green technology policy. Okay, we adopt the green technology policy not only in power generation, but it covers practically everything, every businesses in Malaysia. Okay, you can see here in 2009 we have the Green Building Index. This is on our construction of new buildings. Then it also cover the solid waste. Okay. And then we have the energy efficiency action plan. You have SEDA Act. Okay, the Sustainable Development Agency in Malaysia under the MESTEC, and so on until we are at 2016 here. So the key challenges in delivering sustainable power supply, okay, to the nation, there are of course many challenges that we have. These key challenges can be divided into three. Okay, the first one is on the energy sustainability as well as security. We cannot run away from the energy security because this is the heart of a nation's development. Then the second one, we have the economic sustainability as well. And the third one is, of course, with regards to the environmental sustainability. Okay, for the energy sustainability, let's have a look at what are the important points here. Okay, the challenge of adopting this sustainable power is that we still have availability of fuel. We still have the availability of hydrocarbon fuel, which technology has been proven and has been utilized for so long. So this would be a big challenge for all the sustainable power or for all the renewable energy technology to move forward, because if the fuel is already there, so we might as well want to utilize this fuel and get our electricity. So that's why the growth of this renewable energy is kind of slow. I mean, it hampered by this availability of fuel and gas as well as coal. And then we have the limitation of alternative fuel. Okay, nuclear is out of question at the moment. Hydro and also other renewable energy, I would say that we have that technology, but in terms of their efficiency, we still cannot beat the efficiency from the fossil fuel technology. Okay. And then we have this difficulty in securing right of way for the transmission line. This is especially true when we talk about hydro or micro hydro, whereby the location at which the station or the power plant is placed, usually it is very remote, right in the middle of the jungle, and therefore you have to construct this transmission line and it involves a lot of stakeholders, especially the state government. So somehow we need to get the permission for the right of way for our transmission. This is also kind of hurdle for power generators or for the company that deals with the transmission. Then we have limited site for the future power plant. Since we are talking about Malaysia, most of the site which is located close to the sea has been fully utilized to cut the cost of the cooling water source. So currently the site left is very limited. So that is another challenge. In terms of the economic sustainability, we are talking about the impact on the global economic crisis. Okay, then we have fluctuation in the fuel prices, so it is kind of difficult to predict what will be the future price of coal, as an example. Okay, regional competitiveness, and then you have problem in terms of electrification for the very remote area. This can also cause the economic issue when you talk about constructing the transmission line right through the jungle. I think for the environmental sustainability, in terms of the limitation or in terms of the hurdles, it's not necessarily straightforward. When you talk about environmental sustainability, we are talking about a climate change issue that is highly associated with the burning of fossil fuel. We have sometimes in certain country stringent emission standard and global concern on the carbon emission. For example, maybe in the United Nations side, they are talking about limiting certain pollutant emission to be below the certain level. Okay, and then as a country, we might have to abide by the regulation if you still want to follow the United Nations standard. So this will be another big hurdle for us to follow. Okay, and then moving forward to the future, we know that the current trends will significantly impact or disrupt the power industry. So we are talking about what are the major trends or shifts in terms of the changing of the landscape for the power generation industry in Malaysia, or maybe throughout the world. So we are talking about the economic shift. Okay, and then we have capital requirement in terms of the changing on their returns, as well as we are talking about the sustainability. Okay, technology disruption. So now we have, everybody is talking about renewable energy. So now the shift has been moved towards energy efficiency, RE, the electric vehicle, battery storage, and whatnot. So these are the new trends, even though we know that the maturity of this technology is yet to be proven, but I believe there are a lot of research or a lot of money has been spent towards the investment on these areas. Okay, and then in terms of the regulations as well, has also been changed. For example, now in Malaysia we are talking about the smart grid. Okay, because of a bit in line with the introduction or in the increase in the contribution from the alternative energy or renewable energy. Okay, so in terms of the advances in the power generation method, so we will cover, as I mentioned at the beginning here, one is on the technology, okay, for the renewable energy, commonly or practically applicable in Malaysia. And then the second one is we are talking about the technology, how to control the emission. So in terms of renewable energy in Malaysia, currently we are focusing on biomass, solar, biofuel, biogas, fuel cell, and also wind. Okay, the small scale wind. And then for the clean coal technology, we have to we can modify the existing coal plants, because as you can see, maybe 20 years ago, 30 years ago, we already constructed our power plant, and that power plant did not come with the system to clean up all the emission before release to the atmosphere. So what we can do now is we can add a new technology or a new system or subsystem that can control the pollutant emission. I think for the new power generation technology, the new technology has to be embedded already inside this technology. Okay, we look at the renewable energy source, typical one, a common one. In Malaysia, we have plenty of biomass. So now we are talking about biomass. Okay, biomass by definition is an organic raw materials. Okay, they might come from plant, they might come from animal, okay, which are destined for industrial or energy use. So typical biomass, for example, we have wood chips, oil palm waste. Okay, this is the one that is abundant in Malaysia when we talk about oil palm waste, rice husk, and also municipal waste. Okay, and then maybe in overseas, their biomass can vary. Okay, mostly they use wood, they use crops like maize or wheat. Okay, they can also use their garbage, put it in the incinerator, and then you got the heat out of that. Can be also from the landfill gas and many other different types of plants. Okay, later on, maybe you can go to the Moodle page and try to look at a few videos that I have linked to in order to get a detailed or clearer understanding on how this biomass or any other source of renewable energy works. Okay, in Malaysia, the greatest potential for the biomass, they come from the oil palm industry. We know that we have a number of, huge land planting the palm oil, okay, and then this after you harvest the palm oil, there are residue from the fruits. So this one can be utilized to generate the power. Power generation potential for the existing palm oil mill can amount to around 400 megawatt. So that's kind of big megawatt, okay, from the biomass source alone. So we have, previously we have a number of incentives provided by the government. Okay, as an example, the SREP, the Small Renewable Energy Program by the Pusat Tenaga Malaysia. Usually for the biomass plant, okay, mainly all the plantation, they have some kind of factory inside there. So this palm oil factory, they will generate their own electricity from the biomass. Okay. These are the example of the biomass fuel. If you talk about the palm, okay, the palm fruit, this is the example of the oil palm fruit. Then this is what is left after you harvest the fruit. So this is called the empty fruit bunch, EFB. And this EFB is actually contains certain amount of calorific value at which when you burn it, you will get a certain amount of energy. Maybe not as high as the energy produced by coal, but if you have many of these, definitely the amount of heat produced is significant, and so you can utilize that heat to get the steam. In some cases, we can send the empty fruit bunch, okay, to a processing plant whereby they convert the EFB to a pellet. So this is much easier to burn inside a boiler or any combustor. These are some of the statistics comparison between the bagasse, rice husk, palm waste, and also wood waste. Okay, bagasse is the leftovers, okay, from the sugarcane, right? Sugarcane, after you harvest the sugar, what is left is called the bagasse. And then rice husk is from the rice plant. So the balance for, after you harvest the rice, you get the rice husk can also be used because we have a huge amount of, rice field in Malaysia. So this is another potential. Palm waste is from the palm oil, palm fruit. Okay, and under the palm fruit, you can have different types of biomass. You can get the fiber, you can get the shell. Okay, just like a coconut shell. You can also get the empty fruit bunch. And then wood waste is another example. So if you look at the composition, usually what we are interested in is we look at their heating value. Heating value indicate the amount of heat that it will produce. So you can see the heating value is quite a lot. For example, the sugar, the bagasse here is around 7. This one for rice husk is around 13 megajoule per kilogram. Okay, wood waste around 9, and then for palm waste, the shell, the tempurung for the palm fruit is around 15 megajoule per kilogram. Okay, another challenges or challenge that we usually encounter when you want to burn the biomass is the moisture. Usually biomass, they contain a lot of moisture. Okay, these are given here for the sugarcane bagasse. You have around 50% moisture. That's a lot for you to dry it first before you can burn. Rice husk is around 10%, and then for the palm waste, it depends. Okay, for the fiber, the moisture content is high, 40%. For the shell, it's around 10. For the empty fruit bunch, EFB, is around 60%. Okay, and then for the wood waste, we have around 47%. So that is the kind of moisture content that we usually need to dry it first before we can burn it into our furnace. Okay, this is a comparison between biomass fuel and coal. So let's have a look in terms of their comparison for maybe heating value and also moisture content. If you compare biomass with the coal, okay, usually the coal have higher heating value and less moisture content. Okay, and then biomass, they have high moisture content, slightly less heating value. So this is how it compare. When I talk about coal, the coal that we do the comparison here is actually based on the low grade coal. Low grade coal ni, for example, when you have sub-bituminous, lignite or semi-anthracite. Okay, there are many plants already up and running in the world, especially in Japan here. So you can see a typical plant that fire the biomass fuel combustion. In fact, in Uniten, I think there is an experiment conducted in collaboration with the Ishikawa Jima Harima, Aisha from Japan, to test different types of biomass fuel currently running in our mechanical engineering lab. Okay, when we talk about biomass utilization, there are actually many technologies related to the biomass. But before that, let's have a look at some of the terms that we usually use to be defined. Okay, when we do some kind of analysis on the biomass. Okay, you have fermentation, digestion. Okay, and then we have landfill gas. Okay, these are related to the biochemical conversion. Bio here, it involves some kind of bacteria, okay, or living microorganism that do the conversion. Okay, maybe from the waste into some kind of gases. So this is under the biochemical conversion. You have fermentation, digestion, and also landfill. Then we also have thermochemical conversion. Okay, thermochemical conversion, it refers to the heat. Okay, it refers to the thermodynamics and also chemical. So it doesn't involve any bacteria, but the one that do the conversion is basically they come from the heat. Example given is the pyrolysis process, the liquefaction, and gasification. Okay, and then we have the direct combustion. This one is direct, you just do the combustion directly. Let's have a look later on here. Okay. For the biochemical conversion, we have fermentation. What is the meaning of fermentation? It's a chemical process by which the molecule, okay, of the item, such as glucose, are broken down anaerobically. So in other words here, you have to have some kind of living organism to do the job, to break down the content, and then at the end of the day, it produces the gas. So you can utilize the gas for other purposes. Digestion, okay, it is more or less similar, breakdown of biodegradable material, okay, but this one, it happened in the absence of oxygen. So usually we are referring to the anaerobic digestion, like the one you can put in your waste. I mean your unwanted food, you can put it in the digester. You later on when the bacteria they start to churn out all this food, it will produces gas. It can produce methane, whereby we can utilize the methane later on. So that is referred to the digestion. And then for the thermochemical, we have liquefaction. Okay, liquefaction, as the name implies, we convert the solid fuel into liquid fuel. Okay, we can also have gasification. We convert the solid fuel into gas directly. So these are the process that we can use to do the conversion of different types of fuel or materials. Okay, landfill gas, you can do this, you can extract some kind of gas. We are talking about methane from our landfill areas. Okay, where I mean the municipal waste that is collected by the district will be dumped into a landfill, and actually this landfill has the potential of producing a lot of gases. We have a number of pilot plants that try to extract these gases and then produces electricity. These are the typical process. You have a landfill here, and then you have to put in some kind of gas well to absorb all the gas that is produced from the landfill. Okay, bring it to a condensate vessel. You have to clean up the gas, then only it becomes methane, and then you have to put it in your small power plant on site. Okay, coupled to the generator, you can get the electricity. So this is a typical plant or small plant that we have in a landfill. Okay, the issue is that sometimes the amount of gas is uncertain, maybe especially it become less during the rainy season, as an example. Okay, pyrolysis is another important thermochemical conversion. Okay, the pyrolysis usually it involves heating of an organic material such as biomass in the absence of oxygen. The keywords here is in the absence of oxygen. You want to extract the gas, okay, we heat up the biomass or the material, okay, and then the material it will produces gas, but it has to be done without the oxygen lah. If oxygen exists, there might be possibility of spontaneous combustion. Okay, the material does not combust, but the chemical compound are broken down. Okay, the chemical compound like cellulose or hemicellulose will be decomposed into combustible gases. And these combustible gases actually you have to clean up. Okay, it can be condensed. Either you can convert the gas into the liquid. So if it is converted into liquid, you call that bio oil. If it is converted into gas, you can call it syngas or biogas. it can also be converted into solid. So we call it a biochar. So the product of pyrolysis ni you can divide into three. Either it can be converted into gas, liquid, or solid. Okay, the proportion of this gas, liquid, solid, it depends on the condition, the surrounding condition, or it depends on several factors that can include the composition of the material that put in, the feedstock, and also the process parameters. So this figure it illustrates on how do we get the three product from a typical pyrolysis process. Okay, this is the gasification, how you convert the solid fuel into gas. Usually we apply it to coal. So rather than burning the coal directly, okay, we try to do the conversion from the coal. You make it convert into gas. Then you clean up the gas before you can before you can utilize the gas. You can also even put the gas in your gas turbine to get the power. So we call the process gasification process. And then of course, the simplest method is the direct combustion from the biomass. You dry it, you remove the moisture, and then you put it in your boiler, you put it in your combustor, you burn it directly. So you obtain your heat, okay, from that process. You can have direct combustion, you can also have co-firing. Okay, direct combustion means you burn biomass as it is. Co-firing, it means you have to blend, you have to mix your biomass with other fuels such as coal. Okay, so that is on the biomass side, which is plenty, abundant in Malaysia. So that's why that would be having a high potential in terms of if you want to go for renewable energy in Malaysia. The second one is solar. Okay, people are talking about solar, the large scale solar or the small scale solar. So this solar is referred to the conversion of light, okay, from the sun to the electricity. Of course, you want to convert it into electricity, you have to have a photovoltaic cell, okay, via solar cell. Okay, a standard measuring numbers, it says that 1 meter square of an area of the earth, 1 meter square, can provide around 1 kilowatt maximum. So you can imagine how much land square or land you require to produce 1000 megawatt as an example in comparison with a typical coal-fired power plant. So one of the disadvantages of using this solar is that it requires a huge amount of land area. So this is the disadvantage lah. Okay, however, if you look at the condition, Malaysia, the average daily solar radiation is around 4 to 5 kilowatt hour per meter square, which is good, okay, to be considered if you want to adopt the solar photovoltaic cell. Okay, and then the sunshine, the average is around 6 hours per day. And then somehow rather it depends on the monsoon season as well. A typical semi-D house, it can produce around 3 to 5 kilowatt hour of power. And then the conversion efficiency for this solar is only 18%, 18 to 20%, I would say. So you can use this as a comparison between solar about 20 lah. Let's say we say 20. We compare a typical power plant efficiency is around 40%. So you can see we still need to improve the efficiency of our solar photovoltaic. Major concern on the solar installation is the area of land required, and also the cost of installation, okay, which is considered high. Because of the high installation cost, somehow it will be reflected on the price of electricity later on, and also the reliability. Okay, reliability, it means that our solar photovoltaic cell can only operate, or our power plant can only operate during the day. Okay, at night you cannot generate the electricity, no sun. Another alternative is for us to install battery to store the energy, okay, during the day, and at night you can supply the electricity from the battery. But then having battery, there is another issue as well, okay, because the amount of battery you require must be very high. I mean, the amount is a lot. The battery can consist of a few different buildings just to store the battery itself. So these are kind of limitation for us to think about in terms of how we can best utilize the solar power in Malaysia. Okay, this is the illustration or a typical figure that describes the working principle. It's very simple. You just need to have the solar panel. The solar panel will do the conversion for you. So we have electron moving through a circuit that produces the electricity. Okay, it's for solar voltaic. We also have solar heating. Not only the sun power not only can produce the electricity, but in addition to that, we can also utilize the solar or the sun ray to our solar heating. Solar heating is much straightforward in the sense that you are getting the hot water, okay, out of it. So you have to have a solar collector, okay, heat up the water will go to your tank. This is your storage tank for hot water, and this hot water can be utilized either for your daily use, or you can also utilize the hot water to heat up a house, especially for the cold countries. So that is on solar, some brief descriptions on the solar energy in Malaysia. The next one we have wind, which is not that popular as compared to solar and biomass, because our wind is not consistent. So it is kind of difficult to have this installation of wind turbine or wind power, unless you are talking about the very small scale wind. But nevertheless, wind, we are extracting their kinetic energy. Okay, wind energy, it depends on the speed of the wind. So we try to harvest the kinetic energy through the wind blade. Okay, wind energy is actually proportional to the speed of the wind to the power of 3. Okay, for the wind energy, typical conversion is quite high, about 50% compared to the solar, compared to the biomass. So typical turbine, it will start to rotate when the wind speed is around 4 meters per second. And then when the wind is getting very high, up to 25 meters per second, there are some kind of cut-off value just for the safety. Otherwise, the wind blade will fall off from the hub. Okay, and definitely it is not desirable. So that's why this kind of safety feature is required in any installation of wind turbine. Okay, some of the disadvantages of the wind is, first of all, is finding the suitable site. We cannot simply put in the wind turbine right in the middle of the city as an example. It has to be located at the place where you have very much consistent wind. That's why we don't have that kind of facilities or that kind of scenarios in Malaysia. So wind is not a good option for us to go for. Okay, and then another disadvantages of using the wind is the visual impact. Okay, it doesn't look nice, especially when you have wind turbine being built on the hilly mountain, and also it produces a lot of noise. Okay, some illustration on the working principle. This is very, in terms of the working principle of the wind turbine, It is very, very simple and straightforward because you are harvesting the kinetic energy. At the end of the day here, the kinetic energy, you get the rotation. Okay, we just want the rotation of the shaft. Okay, we just couple to the generator, and then it produces the power as simple as that. Okay, and the next one is on the fuel cell. Okay, fuel cell. It is not a battery, but we are talking about electrochemical device in which energy of the chemical reaction is converted directly into the electricity. Usually for the fuel cell, okay, we are harvesting the hydrogen. We are harvesting the hydrogen with the positive charge. Okay, this after hydrogen, the electron has been extracted to run through a circuit. Okay, what is left is hydrogen positive, which later on, you have to supply the oxygen for the whole process to work. Right? It requires hydrogen and oxygen, which is obtained from separate processes and catalysts. So at the end of the day, you got the electric. Okay, at the same time, you produces water, hydrogen combined with oxygen, you obtain the water. One issue on the fuel cell, usually we are talking about how do we obtain your hydrogen gas. So that is always a big concern because getting a hydrogen gas is not a straightforward process. Okay, hydrogen gas, in order to get the hydrogen, you have to put in some energy. You have to come up with a process, okay, to get the hydrogen. Hydrogen gas can be obtained from the from different processes lah. Okay. Usually this fuel cell now mainly they are adopted in the vehicle. In the power plant also it is possible, but there are plenty of work needs to be done on that. Okay, we also have just now we have biomass. Now we are talking about biofuel. Okay, biofuel is a process at which we create fuel from either from the plant or from the dead animal. Okay, biofuel can be from the crude palm oil, okay, CPO, and also palm diesel, or it can also come from any other source of plant. Okay, crude palm oil. When you talk about biomass, you know that biomass comes from the product of palm fruit. Okay, now we are talking about the fruit itself. Okay, after we harvest the oil, okay, that oil can also be converted into biofuel. Okay, crude palm oil here can be used as the fuel when mixed with the medium fuel oil, and actually from the oil that you use for cooking, it is actually can be converted into oil that we can test, we can fire in our power plant or inside your internal combustion engine. We can also have palm diesel, okay, crude palm oil, you convert, okay, the palm oil, you convert directly into diesel, of course, with several processes in between. Okay, so this is another options available. You get the biofuel. Okay, it can also come from plant and also animal. For example, algae and others. Okay. Okay, let's have a look here at the biogas. Okay, biofuel just now, usually it is in the liquid state. Okay, for the biogas, it is actually a mixture of different gases, okay, produced by the breakdown of organic matter in the absence of oxygen. So for biogas, it can be produced from raw material such as the agriculture waste, okay, cow dung or cow manure, okay, municipal waste, plant material, sewage, green waste, and also food waste. So all these waste, you can actually use some kind of anaerobic digestion to produce the biogas. Okay, produced by anaerobic digestion, and then it will produce gas. Okay, the gas usually it consists of methane, CH4, and also carbon dioxide. Okay, and also it may have a small amount of hydrogen sulfide, H2S here, the one that gives you the bad smell from this product. It contains some kind of water, moisture, and also siloxane. So somehow this needs to be, I mean, you can do the cleanup before we can utilize the CH4. Okay, it can be used for any heating purposes such as cooking. It can also be used in a gas engine to convert the energy into the electricity or into the heat. Okay, I think that's all for today. We'll cover mainly on the typical renewable energy options, okay, that we can utilize mainly in Malaysia lah. I mean, actually there are many other source of renewable energy. You can also have ocean energy, okay, geothermal and everything. But that is, I mean, currently it is not practicable in Malaysia. So that's why I focus on what are the current trend in Malaysia. Okay, currently being utilized in producing the electricity. We are talking about okay, biomass. We're talking about wind, very very small, fuel cell, solar, biofuel, and biogas. So I guess we will stop now, and then we will continue for the rest of the technology.